All right, here we go. 1.5, factoring. This is a very important section. We'll do factoring the rest of the semester. So, which is kind of good on the one hand. You'll be learning, you'll get better and better as we go throughout the semester because we'll keep doing it and doing it and doing it. But also you do want to kind of get it down because it'll be a necessary skill for the things we do. All right, so 14x to the 6th plus 6x to the 4th plus 2x cubed. All right, so we're supposed to factor. Now, what in the world is factoring? What are we even talking about? What does it mean? They're going to say factor for all 30 problems. They're going to say factor. What does that mean? Factor. What's that? Break it down. Factor means to unmultiply. It means find out what it was before it was multiplied. It means to reverse multiply, unmultiply. Let me just write that. Factoring is unmultiplying. Now that seems kind of weird, doesn't it? Like why would anybody want to unmultiply? It's actually very useful for all kinds of real life applications. All right, so what are we talking about then? They're saying this is the answer to some factoring, to some multiplying problem. What was the problem? That's what they're asking us. They're asking us to backtrack and find out what two things were times and became that answer. Well, here's how you do it. You first off have to find, step number 1 is to find what's called the GCF. Stands for greatest common factor. The GCF, the greatest common factor. And what the greatest common factor is, it's the biggest, or greatest, same word, greatest number that will divide into 14, 6, and 2. I just grabbed the 14, the 6, and the 2. I just grab those three numbers and I find the greatest number, the biggest number, that'll divide into all those numbers. In other words, what do they have in common? What goes into all of them? 2. So we want a number that divides into them, right? 2 goes into 14 7 times, 2 goes into 6 3 times, and 2 goes into itself 1 time. So 2 goes into all those numbers, doesn't it? So that's the number part of the GCF. Now for the letters, you take the lowest power. So as you look at these powers, what's the lowest one?
2.
X to the 3rd. So the GCF is going to be 2x to the 3rd. And then you put a big old parenthesis. So this is the GCF, the greatest common factor. That's the most they have in common. Is that making some sense? So that'd be like what if I said Dennis has 3 quarters in his pocket and I have 2. What's the most we have in common?
2 quarters.
2, right? We both have 2. We don't both have 3. He has 3. I only have 2. Right? You with me? So do you understand? That's what we just did with the powers. Whoever has lower, me or Dennis, that's the most we both share in common. That's what we just did with the powers. Somebody has 6 quarters. Somebody has 4 quarters. Somebody has 3 quarters. Looking at those powers, how much do they all have in common? 3. They all have at least 3, don't they? That's why it goes up. That's the greatest amount they have in common. See how that really is the GCF, even though it's the lowest power, it is the greatest amount they share in common, isn't it? So that's what we're really finding. We're finding the greatest thing they share in common. They all have at least 3 X's. Some have more. 2 goes into all of the numbers in the front. So this is the greatest thing that goes into all of them. It's the greatest common factor. Making sense? Now, that goes on the outside in the very front, and then so put that in the front. Step 2, so GCF in the front, and inside, how do you know what goes inside? Well, there's going to be 3 blanks in here with the plus sign and the plus sign between the stuff. Inside, whatever multiplies to go back correctly. Can you read all that scribbling? So you put the GCF in the front, and inside you put whatever multiplies to go back correctly. Whatever multiplies to go back correctly. So what am I talking about? I'm saying 2x cubed times what? In fact, let me do it on the bottom here. 2x cubed times what will go back to 14x to the 6th. Because remember, we're unmultiplying. That's what factoring is. We're figuring out what would multiply and go back. What was it before it was multiplied? What would multiply and go back correctly? Remember how it works? Out front numbers multiply, powers add. So 2 times 7, and powers add, so what power do I need? 3. And that'll go back correctly. Makes sense so far? How about the second one? Yeah, out front numbers multiply, 2 times 3 is 6. Powers add, x to the first, or just x. Because the 3 and the 1 powers added before. Last one, you do need a 1 there. Yeah, you can't put a blank, because 2x cubed times nothing would be nothing. Got to put a 1. And it's done. We just unmultiplied it, right? If you were to remultiply that thing, it would go back, wouldn't it? We just took it apart. We found out what it was before it was multiplied. We undistributed it, if you will. That's what factoring is. Breaking it down. Factor, which means find out what it was before it was multiplied. So you got to find the GCF first, the greatest amount they have in common. So use your calculator if you're rusty on some of those times tables. Find what number divides into all 3 of those numbers.
5.
Right? And then take the lowest of the 3 powers, because that's what they have in common, right? That's the greatest amount they have in common.
So it's 5x to the 7?
Exactly. So 5x to the 7 is going to go in the front.
Wow.
Y'all seeing that?
That's funny.
So that's our GCF, right? Because 5 goes into all those numbers, 25, 10, and negative 25. And then you take the lowest power, because that's what they share. That's what they have in common. Put one big old parenthesis. Put the plus sign and the minus sign in there, you know. You got the 3 blanks with the plus and the minus between them. And now figure out what would multiply correctly. Give you a second. Exactly. So 5x to the 7th times what will go back? 5 times 5 would be 25. Powers add, so really we just subtract to find out what it was. X to the 12th, huh?
Yeah.
And 5 times what will go back to 10? 2. X to the 5th, because the power out front numbers multiply, powers add. And then 5 times 5. Oh, yeah, just 5, huh? No X is it. Now, some common mistake, some people will say, well, I'll just put an X there like that.
Then it would have been turned to an 8.
Yeah, because that'd be 1, and that'd be 8, and that'd be wrong. Yep. You got it. There it is.
Can I take my SAT?
We good there? Questions on that one? All right. I'm going to move ahead. All right. If you're good, I'm going to go to number 5. I think you're good on that. So I'm going to move to 3 and 4, the same thing. Well, you know what? Let's do one more. I don't want to be too fast. I want to make sure you're getting this. This is important. One more. So 15, number 4. 15y to the 17th minus plus 35y to the 10th minus 15y to the 5th. What number divides into 15, 35, and 15? 5, and what power? Y to the 5th. There's our GCF. One big parenthesis. 3 blanks plus and a minus. 5y to the 5th times
3y to the 12.
3y to the 12th. Out front numbers multiply, powers add. That'll work. 5y to the 5th times
7y to the 5.
7y to the 5th. Yeah. So out front numbers multiply, powers add.
Subtract 3.
And 3. Out front numbers multiply, powers add. That good? Yay. All right. So we're still factoring. The whole section is factoring, which means, find out what it was before it was multiplied. Unmultiply it. Now this one's a different animal. First off, do you notice if we tried to do the technique we just did on the last few, it wouldn't work. There's nothing in common. The first one doesn't have any number at all. And they don't even all have a Y. The last one doesn't even have a Y. There's no letters in common. There's no numbers in common. That ain't gonna work. We need a new technique. It's dramatic, huh? That noise and the flickering of lights. All right, so we good? We need a new technique. So what do you do when you have 3 terms? I want you to... factoring is mainly about recognizing how many terms. I should start building for you an overall factoring strategy. Step number 1, look for GCF and 1 big parenthesis. That's what we just did in those other problems. Step 2, if you have 3 terms, which is what we're on to now, put X's in the front and write multiply, add, and I will explain. So for 3 terms. So I'm putting together for you now an overall game plan for factoring. Factoring's super important through the rest of this course and on not in statistics, but in everything else, basically. Pre-calc, calc, if you're going that way. So first thing you should always look for is a GCF. We looked for it. There is no GCF on this one, right? There's nothing in common. But it's a good habit always to look for that first. Second step. Okay, now if you have 3 terms, what you do is you write 2 parentheses. So it's going to be 2 parentheses with, or X's or Y's. In this case it's Y's, huh? Y's in the front. And you write, notice I'm writing multiply, add. Where's that go? It's kind of floating in my example. The multiply goes over the last number, and the add goes over the middle number. In other words, I'm looking for something here and something here that multiplies to be 28 and adds to be 11. What 2 numbers multiply to be 28?
7 and 4.
Yeah. And use your calculator if you're rusty on some of these times tables. 4 times 7, the order doesn't matter. 7 times 4, 4 times 7, whatever. Both positive, right? Positive 4 times positive 7 multiplies to be 28 and adds to be 11. We're done. That's the problem. Now, just for fun, I want you to see why that is true. Let's check it. And I think you'll learn a lot through the check. Not required. You don't have to check it on the homework or anything. You know, all the program wants is this answer right here. They just want you to type in the 2 parentheses, y plus 4, y plus 7, either order, doesn't matter. And the homework system, my open math, will be happy. But let me prove to you, and this will deepen your understanding, that that's really right. Let's take y plus 4 and y plus 7 and multiply them, and we'll see that it goes right on back to this. That's what we're claiming, right? We unmultiplied it. All right, let's remember how to multiply 2 things with 2 things?
Yeah,
Boom, boom, yeah. Y squared plus 7y, and he's done. So the first to both, and now second
4y.
to both, yeah. Boom, boom, 4y, and 4 times 7, 28. See what these 2 in the middle do?
Turn to 11y.
See why I wrote add now? That's what happens when you multiply 2 things with 2 things. The middle ones add, don't they? And where'd the 28 come from? Multiplying. That's why we write multiply add. We're just thinking it out backwards. Does that make sense? You see how when you multiply 2 things with 2 things, you end up adding the two numbers in the middle because they're like terms, and the number at the back comes from the multiplying of those numbers. That's just what happens when we multiply two things with two things. So if we're thinking it out backwards, we should say multiply for the back number and add for the middle, and find two numbers that multiply to be the back number and add to be the middle number. Question?
Is there a third way to find if I had to put those in my 3x5 card?
Whatever is helpful to you. So x squared minus 11x plus 24. All right. Factor that one. So step number 1 is look for GCF. Is there a GCF there? Is there some number they all have in common? No, the x squared doesn't even have a number in the front. Is there some letter? Do they all have the same letter in common? No, the 24 at the back doesn't even have letters. So no. Skip that. Go right on to step 2. For 3 terms, what do? 2 parentheses, x is in the front. We think about multiply, add. So you should write multiply, add, do the 2 parentheses, x is in the front, find your 2 numbers. All right, so what 2 numbers multiply to be 24? Yeah, good. Use your calculator if you're rusty on some of those times tables. 8 and 3, huh? But, 4 and 6, 2 and 12. There's lots of numbers that multiply to be 24, but these are the 2 that can make the 11. What signs do they need? Notice what I'm doing. Everybody notice for a second. I write down the numbers first with no signs. Either order, you can put the 3 here, the 8 there, doesn't matter at all. But the signs, those will matter. Now, you know where you get the sign from? The middle tells you about the signs. How are you going to get negative 11? You got to lose $8 and lose $3. That's a big minus sign there. You got to lose $8 and lose $3. Then you lost $11, and they multiply. 2 negatives multiply to be positive. It's all right, isn't it? Remember how 2 negatives multiply to be positive? But they'll add to be a bigger negative, won't they? Either order, you can have the minus 3 coming first, then the minus 8. Is that making sense?
Yeah, I know so.
Shall we try another one? Let's try number 7. All right, let's try number 9. How about? I'm going to jump down a few. Number 9. X squared minus 2x minus 80. First question, is there anything in common to all 3? Step 1, look for GCF.
I thought it was
But the front one doesn't have a 2.
right.
Doesn't have any numbers at all. So there's no numbers. Do they all have a letter? No, the back one doesn't have any letters at all. So there's no GCF. So go right on to the 2 parentheses then. So 2 parentheses, x is in the front. We're looking for 2 numbers that multiply to be 80, add to be minus 2. Don't say it out loud. Does that make sense? So if you're looking at that 80, take 80 and just take your calculator. I would divide by 10. Any number that ends in a 0, I think about it's something times 10, huh? So then you get 8, and you go, 8 and 10, and then let's see what else can we do. Divide by 8, you'll get 10 again. So 8 and 10. Divide by 4, you'll get 20, and you go, 4 and 20. Divide by 2. Divide by 2, you'll get, 40? 2 and 40. I think you could divide by 5 also, right? 5 and 16. So there's a whole bunch of numbers. See what I did? I just tried to divide them by different things on the calculator. Just try different numbers. And if you try something like 7 and it doesn't go, then just move on to another number. So I've got a whole bunch of things that multiply to be 80. 8 times 10, 4 times 20, 2 times 40, 5 times 16. If you could read my writing on that bottom one. That's a 5 there. So all those multiply to be 80. Which of them has the potential to add to be negative 2? 10 and 8. Because they're 2 apart, huh? 10 and 8. So notice, I'm not thinking about signs yet. I'm just thinking about numbers. So write them down in either order. I'll put the 10 here, the 8 there. You could reverse it. Doesn't matter at all. Order doesn't matter, but signs do matter. Now, I'm going to give you a very important rule that we're going to use the rest of our time here and all the rest of the section on Thursday. And that's figuring out the sign. A lot of people get stuck on the sign. So notice I first write down the numbers. No signs yet. Here's the rule. The sign in the middle goes on the bigger. That will always be the case. The sign in the middle, this sign right there, is taken by the bigger number. Who's bigger, 10 or 8? 10. He'll take the minus sign. Let me write that. Sign in the middle goes to the bigger number. That'll always work. The sign in the middle always goes to the bigger of the two numbers. The bigger one dominates and forces the sign that's in the middle. So if there's a minus in the middle, the bigger number gets the minus and the other one's plus. That makes sense, doesn't it? If you lose $10 and you gain back 8, the bank account's down 2. And they multiply, positive times negative, to be negative. It's correct. The order doesn't matter. If you had the plus 8 here and the minus 10 there, that's great. But the 8's got to be positive wherever he's at, and the 10's got to be negative wherever he's at. Order doesn't matter, but signs in front do. 8's got to be positive, the 10's got to be negative wherever they're at. Making sense? And then we'll move forward. So let's back up one. Let's do number 8. How about w squared plus 13w plus 36? So it'll be a little easier. So first question, is there a GCF? Is there something in common to all three terms? No, there's no number in the front. They don't all have a W. The 36 doesn't have a W. No. Go on to the 2 parentheses. So 2 parentheses. What multiplies? Use your calculator. So if you're not sure about that 36, just take that 36 and try dividing by various numbers. Yeah. So you got to take that 36 and just try dividing by different numbers. Yeah, well, the order actually never matters.
Yeah, I'm talking about where the rule.
The
sign in the middle forces.
Oh, yeah. That's for sure true, yeah. So 36, let's try dividing. So when I got a number like this, I would just try dividing by things. Like divide by 6, it'll be 6. Divide by 4, it'll be 9. Divide by 2, it'll be 18. Divide by 3, it'll be 12. So these are all numbers that multiply to be 36. You see how that works? Whenever I divide and it comes out clean, a whole number, that means those are 2 numbers that multiply to be 36. Does that make sense? So just take your calculator. You want to get yourself a calculator that you're good with. Don't buy the calculator the night before the exam, right? Or borrow a friend's that you've never used before the night before the exam. That'd be like showing up at a sporting event with a brand new glove or something. You don't want to do that. Or new skates or something like that, right? You want to be well worn in with whatever calculator you're going to use on exam day. Know it well. Practice with it between now and exam day, which is next week. So, right? So get used to using whatever calculator you're going to use on the test. So there's no uncomfortableness that day. So, so these are all options. Which of these have the ability to add to be 13? 4 and 9. So 4 here, 9 there, or vice versa. The order never matters. What signs do we need? What tells us the sign? Sign in the middle goes on the bigger. That's always true. The sign in the middle goes to the bigger, and it also goes in the other one. In this case, it goes on both of them. But it will always go on the bigger. That will always be true. The sign in the middle will always go to the bigger. It may also go to the other one or may not, but it will always go to the bigger one. So there it is, right? Those add to be 13, and they multiply to be 36. Either order. Is that good? Ready for something bigger?
Sure.
A little bigger. We'll ease it up slowly. All right. So number 10. 3w to the 4th plus 33w to the 3rd plus 54w squared. So it just got a little bigger, a little more interesting. What's the first step? First thing we're supposed to look for in every factoring problem? GCF. And remember, you do one big parenthesis on that step before you go on to the second step and do the two parentheses. So is there a GCF here? Let me let you find it. All right, so first off, what's that GCF? We getting that?
3W2.
3W2 is correct, right? We all getting that? Right, because all those numbers are divisible by 3. They all divide by 3 perfectly. And you take the lowest power because that's what they have in common, huh? So, and you put that in the front. And one big, that's why I'm emphasizing one. Because the mistake a lot of people make is they think, oh, they know about the GCF. And then they think, oh, 3 terms, I got to go right to the 2 parentheses. No, first you got to do the 1 parenthesis because that's all the numbers are going to change. And then go to the 2 on the next step. This is a 2-stepper. So first we do the 1 big parenthesis, which is what we always do with a GCF. You've always got to do the 1 big parenthesis when you take out a GCF because the numbers will change. What 3 numbers are going to be in there? Bring down the plus signs in between. 3w squared times what will go back to 3w to the 4th? Remember, out front numbers multiply, powers add. What do I need? W squared. You can put a 1 if you want, but it's not needed. It's just w squared because powers will add and it'll go back, huh? And 3w squared times what will go back to 33? 11w to the first because that 1 power will add. And 3w squared times what? You should calculate, I think it's 18, right?
Yeah, just 18.
No w's at all because we've already got the w squared we need. Bless you. Now, we're not done, right? Now we leave that 3w's. Now that 3w squared, he's going to be part of the final answer. It's just we set him aside. We don't need to do anything else with him. He will be there in the end. He's part of the final answer. Now we go into phase 2. What do we do with 3 terms? Because that's what we're looking at here. 1, 2, 3 terms. What do we do with those? 2 parentheses, w's in the front, and you write multiply, add, right? You know all about that. Let me let you do that. All right, put the w's in the front, find the 2 numbers. Some don't. What numbers multiply to be 18?
That's be 2 and 9.
2 and 9. And add to be 11? Those are them. Either order, you can put the 9 first and then the 2, and there's our answer. So that was both things together. A GCF on the first step with the 1 big parenthesis, and then do the 3-term, 2 parenthesis thing, multiply, add for the next step. And so there it is.
So we're bringing that down to the parentheses.
So I have the answer is the box.
Yeah, that's what I was saying.
Okay, yeah.
Before I was just keeping it as 2 and 9. I didn't bring everything down.
Oh yeah, you need the 3w squared in front still. Yeah, that's part of the deal. We good? Is that making sense? Putting the 2 things together?
It does make sense, W squared.
Okay, let's see. Okay, how are we doing? All right, we're going to change gears, unfortunately. So we're just starting to get that down. We need to change something else. Okay, 2x squared. I'm going to skip number 11 for now. It's harder. I'll come back to it. Let's go on to number 12. These are kind of in a little bit of a funny order. So let's go on to 12, which will be easier. 5x cubed minus 245x. Yeah, let's do that one. Okay. So this one's only 2 terms. Yeah. So do the first step. What's the first step on every factoring problem? Look for a GCF, and if there is one, do 1 big parenthesis. So use your calculator, find out what goes into 5 and 245, and then take out the lower power. What's the lower power? Let me jump in. So what number goes into both those? 5 and x, right? Because that's lower than x cubed, x to the invisible 1 power, huh? So 5x is the GCF. Is everybody seeing that? So you find out what number divides into 5 and 245, it's 5. And then you take the lower power, the lowest power, which is just plain x, x to the 1. And then you put what? One big parenthesis, and you put inside whatever works. This is going to be two terms separated by subtraction, huh? 5x times what will go back to 5x cubed? Out front numbers multiply, powers add, x squared. Yeah, 1 and 2 powers add, don't they? And 5x times what? I don't know. Use your calculator. 49. And you don't even need an x because you already have it from here. Is that good so far?
That's it?
No, unfortunately it's not. Now, you know how we've learned that 3 terms, this is only 2 terms, of course, but 3 terms, we do the 2 parenthesis thing, right? Well, you can also do that sometimes with 2 terms. When?
What is the x squared minus 49?
Yeah, things like that. When the 2 terms, I should say, if the 2 terms are both perfect squares. Now, what's a perfect square? It's the kind of squares Mr. Heron draws. They're perfect. No, has nothing to do with geometry. It's numbers. What numbers is it? Yeah, like 7 squared is 49. 7 times 7. Or 3 squared is 9. Or 2 squared is 4. Or 5 squared is 25. Or 6 squared is 36, etc. Numbers that come from squared, second power. And not only numbers, but also letters. X squared, that comes from 2 x's, doesn't it? That's also a square. So those are both perfect. They're what we call perfect squares. If the 2 terms are both perfect squares and they are subtracted. It has to be subtraction. I'll show you why, maybe tonight, maybe Thursday night. It can't be added. It has to be subtracted. But that is indeed exactly what we have here. 2 perfect squares subtracted.
So what do we do with it?
So what we do is the 2 parenthesis thing. Let's do it. 5x, the 5x still stays in the front, just like on the other one we did the GCF. Whatever's in the front stays in the front. And then we do the 2 parentheses. Now, how do you know what goes in the front? Well, remember, all of this is reverse multiplying, isn't it? So just think, what would multiply? What if I was to start to multiply here, what would go back to x squared?
X.
Yeah, we got to have an x in the front of each one, huh? And what about the back? What times what would go back to 49? Has to be the 7. And how do you get a negative? This is a negative 49.
Has to be a negative.
1 positive, 1 negative. Because positive times negative makes negative, doesn't it? And that's it, we're done with that one. So do you see how it became the 2 parentheses? Let's try that one. 4x squared minus 4. So try to do the same thing we did. What's the first step on every factoring problem?
The transform or GCI or whatever.
GCF, right, GCF. What do they have in common? Do those 2 have something in common?
I thought it was 2, but no.
Oh, no, but that
4
X,
doesn't have a
that
2.
X, yeah.
2 goes into both of those, yes. But we want the greatest number. What's the biggest number that divides into those? 4. 4. Yes, indeed. Better put that 4 in the front and 1 big parenthesis. Don't skip that step.
You don't need to put the X.
Well, do they both have an X?
No, they don't.
Yeah. I would if I could, but I can't, so I don't. Right? No, they don't both have X. If there was an X back here, then I would, remember what we do for letters. For letters, we take the lowest power.
Okay.
So if one of them doesn't have any x's at all, the lowest is none.
Okay.
It's just the 4.
Okay.
Right? Because the one at the back has no x's at all. You with me on GCF?
I am.
You take the number that divides, the greatest common factor, the greatest number that divides into 4, and 4 is 4. 2 also goes in, but that's not the greatest. And then when it comes to the letters, you take the lowest power, and the lowest power is no x's at all. They don't have x's in common. They don't both have x's, do they?
Right.
So we can't take out any x's, just the number 4. What does that leave on the inside?
X squared minus.
Yeah, because that would multiply to go back, wouldn't it? Good so far. That's step number 1. Now, what's step number 2? Are those two terms perfect squares?
No, I thought it wasn't.
It's not.
Oh, yes it is, but negative 1.
1 squared is 1. He's the simplest perfect square. Yeah? 1 times 1 is 1. And of course, x squared is a square. That's x times x.
That is 1. And
So do you know what to do with that?
plus 1 negative 1. Yep.
Right? 4 stays in the front. 2 parentheses.
For some reason, I put 2 by accident.
X and x makes x squared. 1 and 1 makes 1. And what signs do we need?
1's plus, 1's negative.
1's positive, 1's negative to make x squared minus 1. Is that making sense on that? Is that good?
You make us do all these parentheses.
Yeah.